An important principle in programming is use wheels, don't reinvent them. So you might ask, are there toolkits or libraries or reservoirs of code that I can draw on to solve common problems and get them out of the way? And the answer to that is yes. Python has a wide array of standard library modules. And in this video, we're going to learn about a couple of them. And we're going to learn how to bring them into programs and use them. The new keyword that you'll learn along the way is import. And import allows you to import standard library modules. So if we do the following, we open Python, let's go ahead and get it started. Let's import math. Now we can use the dir command on math to see what's inside of it. Okay? You learned last time that the doc string for a function can give you information about that function's action. Now, if you are a C programmer, you'll look at this and you will be in a very familiar area. In fact, if you're a Java programmer, you will also see these are very familiar functions, pretty standard things that you see. Now, let's go ahead and use one of these functions. So how do we use it? Well, since we need to go in the math library, we need to say math dot. Remember, the dot is indicative of the genitive case. So we are going to call math's cosine function on 0. And we all know that the cosine of 0 is 1. We've had it a little trigonometry. Now, I'm going to go math dot sine of 90. The sine of 90 supposedly is 1. Ew. Why is that? Well, let us plumb that mystery by printing out math dot sine dot double underscore doc double underscore wham. Oh, the measure of angle is radians. Now, if you're not familiar with radians, here's an easy description of radians. If you take a piece of paper and a compass and draw a circle of radius 1 unit, doesn't matter what the unit is, inch, centimeter, whatever, or just the width of the compass right now. Measure that out. Make a circle and cut that out with a pair of scissors. Then what you're going to do is take that compass, keep that length, and cut a piece of string that's that width of the compass and wrap it around that circle. And it's going to go about 1/6 of the way around the circle. That radius will go about 1/6 of the way, and that angle, which is subtended in the sector defined by that string, that's a radius. Or another way to think of it is you have your circle and you have a bar of metal, it's made out of metal, and you have a bar of metals that's the length of the radius, and you heat it up with a blowtorch and you bend it around the circle, it will go 1 radian. Now, we all know that a circle's circumference is 2 pi times the radius. So the number of radians in a circle is 2 pi. So 2 pi radians is equal to 180 degrees. And if you think about that, there's your conversion factor. Now, fortunately, instead of 90, the number of radians in 90 degrees is pi over 2. How do I do that? I go math.sine of math.pi. Oh, there's math.pi. It's a constant divided by 2. And wham, there we are. Okay, so that's the sine function. All the trigonometric functions are present. You can see here cosine, right? And somewhere down here is tangent. Let's see, where is it? Oh yeah, there's tangent. Here are these hyperbolic functions that you see on scientific calculators. Those are various combinations of e to the x and e to the minus x. One very nice popular function that is beloved by my students is math.hypot. Let me show you how it works. And if I put in 3, 4, that computes the length of the hypotenuse for a right triangle with legs 3 and 4. We all know about 3, 4, 5 triangles. So any of these functions, you can look up what they do. Hey, let's check out logs. Logs are big and heavy in wood, and they're also very useful creatures. Okay, returns the logarithm of x to the given base. Oh, and by default, the base is math.e. And you might wonder, what is that mysterious constant? Well, I'll tell you what it is. If you draw y equals e to the x, where e is that constant, if you draw that graph and you go to the y-intercept, which is going to be at 0, 1, and you draw a tangent line to that curve, its slope is 1. That's the magic of E. E is very magical. If you want logs of other bases, hey, you're a chemistry nerd, you want log base 10, here's how you do it. You go 10, or let's say log base 10 of 1,000. We'll go 1,000 and then give a second argument of 10. Oh, I need to say math.log. My bad. Okay, and yeah, floating point numbers are not stored exactly, but hey, that looks like 3 to me. Okay, you could also do this. That's called the change of base formula, and it works wham for you. You can see down here, this is insignificant. Fairy dust caused by the fact that floating point numbers are not exact. Okay, so that's the log function. So you have goodness inside of this module. So all you have to do if you import a module is use dir on it, and you can see what the functions are, and then you can go ahead and look at the doc string of those functions. Okay, now I'm going to talk about a second very useful standard library. And this one gives you access to your file system. Okay, so I can go import OS. Okay, and look at that. Holy Nelly! There's a whole lot of things inside of here. All right, and some of them are pretty mysterious. But let's see what we can possibly do. I'm going to give you a little tour here. I'm going to say os.get cwd, empty parentheses. Ooh, that tells you guys I'm working on my Mac right now. And this is the directory that I'm now occupying. Okay, I can do this, os.listdir, empty parentheses, and that's list the contents of this directory. Wow, it's got a lot of stuff in it. Okay, so os.listdir. Let's do this. os.path.exists of, let's see, let's get a file that's in here, new edition, which appears to be in there, and I need to put that in quotes or I'm going to get yelled at. You can see it at the bottom of the list, that huge listing. Hey, look at that. Now I'm going to try it on a file that doesn't exist, pink.elephant. we all know pink elephants don't exist. And there you go. So you have access to your file system, which can be a pretty darn useful thing. You can also print out things like this. You can print out, let's print os.path.exists. Hey, let's get its doc string. Test whether a path exists. Returns false for broken symbolic links. A symbolic link is an alias, and a symbolic link is broken if it doesn't point to any existing file. Okay, so this can tell you if a file exists before you decide to open it. We'll learn about file I/O later. All right. Now here's another thing you can do is if you know you have a directory in here. Let's see. I'm gonna try this. I'm gonna try os.path.list. Now I happen to know this directory exists. A directory called DG. Oop. Oh, I need to get rid of .path. I got overzealous. That's just in plain old OS. All right. And you can see I've got a bunch of files that are sitting in there. So the OS library gives you access to your file system. The math library takes Python and makes it into a scientific calculator. Now that we've done that, there's a couple of other things we should say about importing. You can actually import. Oh, let me get out of here. Control D. You can import your own set of files. And let me show you how to do that, because it's a fairly simple thing. So here's what I'm going to do. Let's see. So I'm going to make a file called lib.py. It's a library. And here's what I'm going to put in it. So we're not going to cover any new territory in programming constructs here. We're just going to do really simple stuff. So is to highlight. All right. Okay. So I just created this file. Okay. And I've called it lib.py. Now I'm going to create a file called client.py. Now, I have thoughtfully placed these two files in the same directory. Okay? Now, what I'm going to do is I'm going to say import lib. All right? Import lib. And then I'm going to say this. I'm going to say print lib.cube of, I don't know, 5. There we go. Hey, I was able to call that function from lib. Now, one thing you're going to see here. Oh, interesting. I thought I might see a PYC file. I do not see that. Okay. So what we were able to do, oh, I know what it did. It's going to produce something. Let's see if I have, yes. All right. I have something called, we'll create a directory called a PyCache. Now, if you import something, you'll get this library. And I've got different libraries that I have in here. But let's see what lib. Ooh, okay. None of that pertains to mine. Interesting. I'm going to get rid of it. Oh. I'm gonna run my program again and see if I get another PyCache directory. Oh, interesting. So it does create this precompiled file, which will speed up the running of your program. You do not have to worry about the PyCache. If it's not there, it will automatically be generated. And it's because the math library got imported. That's where that comes from. Okay, so we now see how to import something. Now, there's more than one way to import. Watch this. From lib import star. And now I'm going to print cube of 5 like I did before. Okay? You can do this as well with a standard library function. The disadvantage to doing this is that you get more names in your namespace. So everything from lib will also be imported, and you won't have the protection of saying lib dot. You won't be able to call things by their full name. So Python first name.py. Okay, here's a better way, by the way, to do that. If I know I want to use 1 or 2 functions from another program, which is also called a module, I'm going to do this. I'm going to say from lib import cube. Now, I can import more than one function. If I want to import square, I can do this. All right. But I'm just going to import cube. And that way I only get one additional name in my namespace. I don't have a lot of symbols cluttering up my symbol table. And now we can say print cube of 5. So if you're using sine and cosine a lot, you can go from math, import sine, comma, cosine, and it makes life simpler. Okay, so here's picky.py. So you can see there are 3 ways of doing an import. So I'm going to cat client.py. So one way to do an import is you import using the import statement, and then you call the functions inside of it by their full names. All right. So this is like last name, comma, first name. This is lib's cube function. We're importing the library lib. This is lib's cube function. The second way you can import is you can import the whole module on a first name basis. So square and cube are both visible. But if this library contained 100 functions, you would have 100 functions that became visible, and you might have a conflict with one of the functions' names. That's why you want to import as narrowly as you can. Generally, the only time I use this from foo import star is if I'm in an interactive session and I'm testing the contents of a library. Then I will do this. But otherwise, in production software, you don't generally want to do this. And then the third way, I just call this the selective import. It's picky. You just pick the function or functions you want to import. So if the library had 100 functions in it and you imported 2 of them, you wouldn't be cluttering your namespace badly. Okay, it's kind of a useful way to think. All right, so we have 3 ways of importing. You can import your own module if you're in the same directory. Now, one thing you should note when you import a module, let's go back to client. You do not put the .py extension here. Omit it. Okay, that's a super common mistake. Otherwise, it's going to look for lib.py.py, and it's going to tell you it's not there. So when you import a module, which is just another Python program, you can leave off. In fact, you must leave off the extension. Now, I'll tell you one other useful thing we can do. This is a nice trick, and it's kind of handy. I'm going to go back to lib.py. Watch this very strange thing. Okay. This does look extremely strange. But I'll tell you what it does. F. All right. Is equal to. All right. You know, here's some test code that I just made. And I make XB5. All right. Now, if I run this program, that test code runs. But if I import that program, the test code does not run. Okay? So this is a very useful trick. And it's very common if you're going to write a library of functions that your colleagues are going to use, you can put your test code here. That way, if something goes wrong, your colleagues can open your library function, see what vulnerabilities you tested, and then they don't have to start at square one. They already know certain things are okay. All right. So this, if _name double equals main, is useful for importation. If this program is run directly from the command line, this code will run. But if this is imported into another file, this code will not run. Now, just to give you an idea, I'm going to go ahead and put an annoying statement down here beyond the end of the if statement. Annoy! Reminds me of my days at the Bergen Academies. Yes. All right. Let's go ahead and run client.py. And you see annoy runs. Okay? So if you want to conceal that stuff, all you have to do is put it inside this if statements block. Okay? So this is a nice way of managing your test code for your own personal libraries. So you learned a couple things in this video. One, you learned that you can import standard libraries, and so far we've learned about OS and math. Okay? Also, you can import your own code. So you can write functions inside of code. You might have a library of functions that do related tasks, and then you can import that program into other programs you're writing and use that as a shared resource, so you're not maintaining copies of those functions all over the place. It's never good to have a lot of duplicate code hanging around. In fact, it's a violation of the 11th commandment, which says, "Thou shalt not maintain duplicate code." So now you know a little bit about importing, and you know something about the OS module and the math module. I would encourage you to go ahead and do a little exploration of those things. You know, you might try to figure out how you get the size of a file using the OS library. You might try to get the permission string for a file, see if you can figure out how to do that, or how you find its absolute path. Those are good things for you to do a little spelunking and for you to figure out. Next time, what I will do is discuss the random library and how to use that to pick things at random or to simulate a simple random experiment.